Hello and welcome to the final part of this video tutorial. In this part I will look at analyzing parallel execution skew using the diagnostics and tuning pack license information. And as in the previous parts of this tutorial, I still stick to the same systematic approach of analyzing parallel execution skew. Which means that there are actually two questions that we need to address. The first one is how can we detect and measure whether there is significant parallel execution skew or not. And then the second question is how can we identify which plan operations are involved in causing the skew and which are affected by the skew, so that we can clearly see on execution plan line level where the skew happens and what operations are affected by the skew, which is crucial for understanding what you can do as countermeasures in order to address the skew. So in the previous tutorial part I showed you how to do that without having a diagnostic and tuning pack license, which is pretty much about using this kind of strange view $PQTQ stat, and also I mentioned that it makes sense to get SASH installed if you do not have the diagnostic pack license to have the built-in active session history. Now with the diagnostic and tuning pack license available, all of this information can now be accessed, and therefore we can easily turn to real-time SQL monitoring, which is part of the tuning pack license. And as I've pointed out in the previous part of this tutorial, the real-time SQL monitoring is the preferable built-in tool, provided tool by Oracle in order to address the first question, whether we have a problem with parallel execution skew or not. In this active real-time SQL monitoring report, which is only available from version 11.2 on, there is then in this different detail tabs, we have this activity tab, and this is the crucial one, which shows you pretty clearly whether you have a problem with parallel execution skew or not. It draws here this line, which is supposed to represent the degree of parallelism, which was in this case 16, as you can see here. So we probably ended up with two sets of parallel execution servers, each having 16 execution servers, so in total 32. And ideally, if you do not have a problem with skew, then for most of the execution time you want to see at least as many active servers as you have a degree. So at least 16 with the given two sets, maybe even more than 16. But as you can see from this graph here, it's pretty obvious that for a very significant amount of execution time, the execution servers were not active. At least many of them weren't active, so there was here something happened, and then we had only a couple of execution servers that were doing something, and obviously the remaining ones then were simply idle, which is exactly what we want to avoid, because then we do not really make use of parallel execution. So that's pretty nice, very nice representation. Visually we can easily grasp whether we have a problem or not. We could, for instance, also see that if we just have this very short period of time where we do not have all this of the servers working, then that's something we do not need to bother, which was one of the points that I mentioned, where the $PQTQ stat is not really that helpful, because it doesn't tell you anything about the quality of the skew. So you might end up with skew that doesn't really matter, but looks quite dramatic in the $PQTQ stat output. But on the other hand, it might look dramatic, and is actually dramatic, like this one here. So that's the good thing of this information here. So yeah, we can very easily tell whether we have to deal here with parallel execution skew or not. Yeah, so that's very nice, and that's great. And another good thing about this real-time SQL monitoring report here is that it doesn't come with all these restrictions that this $PQTQ stat view has. So we can generate this from any session that has the corresponding privileges. We can generate it while the statement is executing. We can generate it after the statement has finished, as long as the monitoring report is still available. So all these strange restrictions that apply to this $PQTQ stat view don't apply to this here. It's not generating garbage if you have this parallel DML stuff and so on. So that's really great that this approach here doesn't come with all these limitations that $PQTQ stat has. Just as a side note, I will come back to that later. This whole information here of this graph, which is shown here by the real-time SQL monitoring report, is actually based on active session history information. So this has in fact nothing to do with specific monitoring information. So that information here can also be derived from the view $active session history, so you do not need a tuning pack license to get that information. But from Oracle's perspective, this kind of report, this real-time SQL monitoring report, of course, is part only of the tuning pack license. So you get the report only if you have a tuning pack license, but that information here is purely based on active session history information. But I will, as I said, I will get back to that later. So the first question of my systematic approach, do we have a problem with parallel execution skew or not, can easily be answered with real-time SQL monitoring and the help of active session history. Now let's turn to the second part, where we want to understand on execution plan line level where the skew happens and which operations are involved and so on. And that's a point where, at least for version 11.2, we really have a problem with real-time SQL monitoring, because all the other ways you can look here at the data that is provided by real-time SQL monitoring, there is simply no reasonable measure that tells you which operations on execution plan line level might be causing the problem or might be affected by the problem. So for example, we can try to deduce things. We can have a look at the activity tab again, and we can see that sometime close to the mid of the operation, so somewhere here in the middle, something goes wrong, and we have this timeline information here, for example. So we might, for instance, we might be able to say that these operations that were only active in the first half, during the first half of the execution, very likely are not the ones that are causing the problems, and are not other ones that are affected by the problem. But obviously there are still many candidates here which might be the problematic ones. So that's not really that helpful. So, and there is no other information on execution plan line level available in this report. So we simply cannot answer this second question very easily using the real-time SQL monitoring report produced by Oracle. There's another tab, this parallel tab, which can also be quite interesting, which shows you the different parallel execution server sets along with some of the metrics that show how much time, database time, how much work in terms of I/O and logical I/O these servers have performed. And if we open this here, we can see here that it confirms that there was a problem with the skew, because ideally you would like to have each of the sets to perform a similar amount of work. Not each, so there might be a difference in the work pattern, in the activity pattern between the different sets, but at least within one set you want to have a similar amount of work performed if the when you have a quite equal distribution of work. Like we can see here that these servers all have spent a similar amount of time in the database. Whereas here we can see that confirmed that one of these parallel execution servers clearly has a different work pattern than the other ones, which is again a confirmation of what we see here, although it's not that obvious. On the other hand, it doesn't help to address my second question, because again here is no information related to which execution plan line this skew is about here. So yeah, that's a problem. So the 11.2 version of the real-time SQL monitoring report actually fails quite miserably with this second question, which is a pity, because now that I know that I have a problem with skew, I need to understand where exactly the skew happens, and if it's a complex execution plan, then you probably do not want to start with some trial and error, like checking which join keys might produce uneven distribution of values and things like that. So that's not really an efficient way of finding out what part of the execution plan is causing the problem. So ideally, I would like to have this simply shown on execution plan line level. The interesting point is that the real-time SQL monitoring information actually provides all the information in these underlying views, in this $SQL monitor and $SQL plan monitor views, to show that information. It can actually be used with some custom queries to extract that kind of information. And it's just that the report that is generated here doesn't really represent the information in a suitable way to answer that question. And furthermore, what is even more interesting, if you open the underlying XML structure that is part of this HTML file that gets generated by this DBMS SQL tune report SQL monitor function, then there is actually a part of this file that talks about skew. So the procedure that generates, the function that generates the raw report information actually does some skew related analysis, and it's also part of this HTML file, but again the Flash GUI here, which uses this as input to draw all this nice visual representation of the report, doesn't really take care of that information. So we already have a hint that maybe in a future version this information might be made available to the end user within the report. So as I said, with the custom query you can actually get the information about the work distribution on the execution plan line level. Right, let's have a look. There are some more problems with or limitations with the real-time SQL monitoring in 11.2. The first one I've already mentioned, which is identify skew on execution plan line level. The second one I haven't mentioned, that is handling of execution plans that have multiple DFO trees. As I've pointed out in the previous parts of this tutorial, with parallel execution there is this concept of DFOs, parent and child DFOs, and DFO trees. If you want to learn more about that, then I recommend watching one of the previous parts where I explain all that in detail. And yeah, real-time SQL monitoring actually has some problems when you end up with execution plans that consist of multiple DFO trees, which is not that uncommon, because when you start using the with clause and you have a so-called temp table transformation, then with parallel execution you can easily end up with multiple DFO trees. And let's have a look at another report to show you the problem that can happen with having multiple DFO trees. There are actually two things that should be pointed out. The first thing is that if we look at this activity pattern here that is shown by the real-time SQL monitoring, again it looks pretty obvious that we have a problem with skew, right? So because we have this initial period in this case where it says it is in this case a degree of 15, but we have far less than 15 servers active on average. And then we have a period towards the end of the execution where we have a lot of activity, and actually it looks a bit weird that we have a spike of activity. More than 60 servers are supposed to be active, were supposed to be active according to this graph here, which is a bit odd, because with a degree of 15 there should be at most 30 servers that can be active concurrently. So you might wonder how this should work out, that we in this case had much more than 30 servers active. There are multiple problems with that. In fact, this line here is simply wrong, because as I've pointed out in the previous versions of this, in the previous parts of this tutorial, each DFO tree can have its own degree of parallelism, and in fact here we had DFO tree active that had a different degree of parallelism than we had active here, and another DFO tree active here that had again a different degree of parallelism. So drawing this line like this here is simply misleading, because the degree of parallelism at this point in time for the DFO tree that was active at that point in time wasn't 15. And also this information here is not entirely correct, because it says the execution used a degree of 15. However, as I've pointed out, there is possibly not a single degree for a parallel execution plan, and this should actually be called, more precisely, this should be called the maximum degree of parallelism detected, which was actually 15. But we also had a different degree of parallelism. We can detect this if we look closer at the execution plan information that is made available in the real-time SQL monitoring report. If we look here, for example, and you look at these px block iterator or hash join operations, then we can see here that for this part of the execution plan, which is this temp table transformation here, we actually have something which looks like a degree of 2, because we only have 2 executions of these operations shown, whereas of course we have for the full table scans the number of granules that were executed. So you shouldn't be misled by this information here. You have to focus on that part in order to understand something about the degree used. Whereas we can see here that for this part here, where we made use of the temp table, we had a different degree. So starting from here, we obviously have a different degree. So that is one way how you can realize that there was a different degree used, but you have to look very closely at the information made available. Another way how you can find this out is by looking at this parallel tab, where we now see not only sets but also groups, which is the way the real-time SQL monitoring makes these different data flow operation trees, these different DFO trees available. So for each DFO tree we have a different group, and if we now dive here into the information made available for these different groups, then we see the different sets, the different parallel execution server sets, and now it becomes obvious that we only have 2 servers per set here, whereas in this DFO tree we actually had 15 servers per set. So that's another way how you can find out that you have different degrees for the different DFO trees. So But as I said, it's not really that obvious. And another point is that this activity here, activity information, doesn't really um, show that information in a correct way. So that is pretty misleading. That it says that the degree was 15 for all of the time. Now, one reason that I've pointed out in the previous parts of this tutorial, one reason why Oracle might have chosen this way of representing the information is that you can end up with all kind of different all kind of different scenarios. In this case, it's pretty straightforward because we have one DFO tree active after the other, which is typically for this temp table transformation thing. But as I've shown to you in the previous parts, you can also end up with multiple DFO trees being active at the same time, and then it becomes a bit messy and a bit complicated to draw this line here, because then you would have to add basically the different degrees for the different DFO trees that are active. So maybe that's the reason why they have chosen this simple way of drawing this line. Nevertheless, for such cases like this here, it's simply misleading. And as I've pointed out in the previous parts, since the parallel execution servers are allocated at each start of a DFO tree, you can end up with different degrees, even if you have, let's say, use the same degree all over the place. You use the default degree all over the place. You still can end up with different degrees if, for whatever reason, the coordinator cannot acquire all the requested number of parallel execution servers. So some parts of the execution plan, some DFO trees, might run with different degrees than the others, simply due to unavailability of parallel execution servers. So it's not that uncommon that this happens, and then you might be in the situation that it looks like this here, and you think you have a problem with parallel execution skew, but in fact you might not have one. So you might have a problem with different degrees. Yeah, and another thing that I've already mentioned that is not that important but can also be confusing and misleading is what I've pointed out here, that this degree here is shown like more than 60 servers active, and so on. So the point here is that it looks like there is simply a bug in the real-time SQL monitoring code. One of the side effects of having multiple DFO trees is that you get a child cursor, a separate child cursor, most of the time per DFO tree. So if for this execution here, which consisted of, as we can see here, of 3 DFO trees, we actually might end up with 3 separate child cursors, and that is simply something for a single execution, 3 different child cursors or multiple child cursors. There can be more than 3, of course. Multiple child cursors for a single execution is simply something that the ones that wrote this code here for the real-time SQL monitoring is something that they didn't really cope very well with. So this is simply a kind of duplication that takes here place. If we had a plan that had, for instance, 5 or 6 DFO trees, then possibly you would end up here with something like 90 or 120 active servers shown, simply because the result at some point is then duplicated 4, 5, 6 times, whatever. So that is some minor issue. It's minor in my point of view, because the shape is still correct, so you still see the shape. It's just that it's the scale is wrong, so you might, as I said, you might here end up with the duplication of data, which is another side effect of this multiple DFO tree thing. So the point here is you have to be a bit careful. Unfortunately, if you look simply just at this activity tab and it looks like this, then typically it's quite obvious that you have a problem with skew. But as I show here, unfortunately, maybe you don't have a problem with skew, but you have a problem with different degrees, and the graph is simply misleading. So that's something to keep in mind, that you cross-check and double check that you are sure that you really have a problem with skew, rather than simply trusting this graph here by cross-checking that you really have just a single degree used or a similar degree used, so that this difference here in activity is not simply due to the fact that you have vastly different degrees used, like I used here in this example. Yeah, and then the third point is the limitation, at least up to 11.2, is the point of availability of the reports. The point is that on busy systems, the real-time SQL monitoring report might be aged out quite quickly out of the memory pool where the $SQL monitor or $SQL plan monitor information is stored. So what I've pointed out as my ideal approach to these two questions is that let's say 2 or 3 days later you should be able to simply generate a report that tells you something about this execution that happened 2 or 3 days or a week or whatever, some longer time ago, and this is simply not given with the real-time SQL monitoring in 11.2, because even if you are lucky, after 1-2 hours or so, it's very likely on a production system that the monitoring report is gone. So on a busy production system, it's more likely that it's gone within a couple of minutes. So that's a pity, because if you come in on Monday and want to understand whether there was a problem with skew during the weekend, then the real-time SQL monitoring report is probably not available any longer. It's something that you can work around with custom code that tries to save the information somewhere, persist the report, or maybe even better, persist the underlying $SQL monitor and plan monitor contents, which is something you can do. But it's not something that is provided out of the box with 11.2. All right, so these are some of the limitations, some of the problems that you might run into when trying to address these two questions, do this systematic analysis that I pointed out of parallel execution skew. Let's have a look at 12c, how 12c deals with this limitations, whether 12c addresses them. And therefore we'll look here at this. This is the same query basically executed in 12c, and this corresponds obviously to this one here, which is the one that really has a problem with skew. Yeah. So this looks a bit different. Actually, I have to say that I like the graphical representation of 11.2 more than what 12c does. Doesn't look that, it's just visually not that nice, but that's probably just a matter of taste. Maybe some find this nicer than 11.2. The point here is that 12c for well, you can see it's quite similar. We still have this degree of parallelism line here, and we have the activity, and again we see here this sharp drop in activity. So this issue with multiple DFO trees aside, this is a clear indication that we have a problem with skew. So the question is now, can we use in 12c some more, some added information, some differently represented information to understand the answer to the second question, where on execution plan line level does the skew happen? And if we turn to this plan statistics tab, then there is actually no simple indicator on execution plan line level. So there is no simple column here where it tells you this execution plan line is somehow involved in the skew. So we do not have that simple indicator that I have in mind that is not available with 12c, but there are some new options available with the 12c real-time signal monitoring. One is here in the activity tab, which is this drop-down box here, where you can select different ways of looking at the data. And there's one thing which is called, one option that is called by plan line, which is something that is not available in the 11.2 report. And now you can see here that you do no longer have the kind of activity shown like on CPU or waiting for I/O or something like that, but you see which execution plan lines were active. And yeah, so that is one way we can, for instance, then hover over this part here, where we can see during this activity part of activity where we had this sharp drop in activity, there were obviously this line 12 and this line 5 here. So these two here were the major contributors to this activity part. So that is a clear indication, a clear relation to the execution plan. And it's not that obvious from my point of view, because you have this different graph here where you then have to remember that, okay, it was line 5 and 12, and now imagine you had here not 2 but maybe 10 different plan lines involved. Then you would have to note somewhere this 10 different plan lines, and then you would have to switch to this plan statistics here where this line ID was added, which was also not available in the 11.2 report version. And you can now see here, okay, we have line ID 5 and we have line ID 12. So these two lines here are basically, according to the graph here, were at least active. So they either were causing the problem or they were affected by the problem. That's something we cannot distinguish that easily here with that given representation. But at least it's a good way of seeing that there were some patterns in terms of execution plan line where we can focus on. So 5 and 12 are our candidates where we would need to focus on. So it looks like, according to this information, that very likely this data redistribution here for this join here was somehow involved in this problem. That probably while redistributing the data for this join here, this DFO information for using this table queue here had caused the problem, which is something we could conclude from this information. And this part here maybe was then affected by the skew problem in this case, because we had then to evaluate something in this view operator, which in this case then was CPU intensive, but that's just something I might be able to tell from that information. So that is one thing that is not available with 11.2. As I said, I do not understand why it's made that complicated, so that I have to switch to this different representation here. Then I have to somehow remember which plan lines were involved, and then I have to switch back to this one here and then check the execution plan lines that were mentioned. But at least it is made available in 11.2. You simply do not have that information available at all. So that's a clear step forward. Then another interesting information is that you can get from this new 12c version is this drop-down box here. And this drop-down box by default shows the activity on execution plan line level for all parallel execution servers. But now you can start to filter on certain parallel execution servers. To admit, I'm not entirely sure how Oracle arrives at these specific 4 parallel execution servers that it shows now here in the drop-down box. As you know, we have 32 parallel execution servers here that are involved in this parallel execution, since we have 2 sets of 16 servers each. But only 4 of them show up here in the drop-down box, and maybe it has to do with the fact that these 4 seem to contribute to at least one execution plan line more than other servers. So, but that's just an assumption. I'm not entirely sure. And then if I click on one of these execution servers, then the information on execution plan line level is then filtered on this particular parallel execution server. So it shows only the activity that is can be related to this particular POOH parallel execution server in this case. And now we could try the following. We could turn here to the parallel tab, then open this parallel execution server set information. Now we can see here what we have also seen in the 11.2 report, that this P007 server was the one that obviously did more work than the others. So this is the one that rather clearly stands out here, that it has worked more than the others, at least within the set. You should only compare it within the same set. So P007 might be our candidate that makes sense to filter on in the other the plan statistics tab, provided that the server is actually available in the drop-down box, because as I said, not all of them are available in the drop-down box of that report. And one more point to this here, depending on the overall complexity and activity of the plan, it's not always that obvious from this representation which parallel execution servers had to do more work. You, for instance, might end up with something where you had multiple occurrences of parallel execution skew, and then it somehow basically the different execution servers end up with a similar pattern of work here, although during different periods of time of the execution you still might have a significant skew. So this is not always that obvious and not always that straightforward as it is in my simple example here. So I've already seen real life examples where you couldn't really identify here on this parallel execution server level that there was skew, because the pattern of activity was pretty similar, but that was just coincidence, because during different periods of time the servers had different periods of activity. So it's not always that straightforward. That's my point that I want to make here. Here it is pretty straightforward. This server stands out. So if we filter now here on this P007, then it becomes again obvious that we might have here a problem with skew, because the total number of rows was 2 million at this point. If we switch back to the overall activity, then we see it was 2 million rows, and if we filter on P007 at that stage, we can see here that all of these 2 million rows were sent to this P007 server, and also here the view and the hash join was then more or less performed by this P007 server on its own. So that is another way you can get an idea of activity skew on plan line level. So again, as I said, it's a bit cumbersome, and you have to click around and switch back and forth to get an understanding. What's also interesting is that if you filter on one of these servers here, then if you hover over these information here, then there is something shown like a skew ratio. So you see here a skew ratio which tells us 1, 1.00, 1.01, which might indicate that there is no skew, but it's not explained. At least I do not think that you find something in the official documentation what this skew ratio is supposed to represent. Interestingly, if I switch now to this case where we really have a huge skew, this skew indicator is no longer shown. So that is really interesting that for those cases where the skew ratio is basically 100%, it doesn't show up. And I know that for these cases here, like the memory, you see this skew ratio, which probably doesn't make a lot of sense. So this looks like a part of the report which probably will be improved in the future, hopefully, and leaves some room for improvement. So maybe with 12.2 or so, or some patch sets, this might be made more useful. So I personally do not know what this skew ratio is supposed to help you, because for those cases where there is no skew, it's shown, and for cases where there is skew, it's not shown. Probably if I hadn't constructed such a case here with such an extreme skew, then maybe this skew ratio would represent something more reasonable. But as it is here in this case, the skew ratio that you get shown here is not really that helpful. Yeah, so that's these improvements that 12c brings us for understanding skew on execution plan line level. Then we had this second point, execution plans with multiple DFO trees. Let's have a look at what 12c does with that limitation that I've shown in 11.2, and for that point, unfortunately, as you can see here, this is again this execution here with this multiple DFO trees. There is not really much of a difference. We still see this line drawn here, which is incorrect in this case, again, because we have a DFO tree active that has only a degree of 2. And we see the same bug still with the caused by this multiple child cursors. So the duplication of data is still happening here because you simply cannot have an activity of more than 60 servers if there are just 30 servers available. So the same problem happens here again. So these points are not really addressed in 12c yet. You still have to be careful with looking simply at this graph, whether it really tells you something about skew or whether this is caused by different degrees. And you can still use the same method of understanding whether you have different degrees that I pointed out in 11.2 report. So here you can see that very likely we had different DFO trees with different degrees by looking at the information that I pointed out. So there is no change in that regarding this point or handling of plans with multiple DFO trees. And finally, availability. In 12c, I think the real-time signal monitoring is in that way enhanced that Oracle simply stores the real-time signal monitoring reports persists them basically in your .wr repository, persists them on disk and makes them available via a new report, DBMS report, whatever package you can use, and very likely, of course, via the enterprise manager. You can access those stored persisted real-time signal monitoring reports. So that's a good thing that 12c automatically stores these real-time signal monitoring reports, but at least during my tests it was quite interesting that these reports here that for those executions here that were made during the tests, for some reason Oracle actually didn't persist those reports, so those are not available via the 8.wr. I don't know exactly why it didn't persist them, but at least there is this, in general, there is this functionality that the reports, at least for the top N SQL, are persisted. So if you are unlucky and your critical statement is for whatever reason not among the top N reports, then it won't be persisted automatically. So it's not entirely sure that you can access that persisted monitoring report even in 12c, because it's not storing all of them, at least not by default. I think you can change that in the options, but on the other hand, persisting all of them might then again be a problem in terms of disk storage. But at least I think you can change the defaults. And yeah, as I said, by default, it's not ensured that you have access to such a old report, because it might have not been persisted due to this top N rule. But at least there is this enhancement in 12c that the reports are persisted, which is not the case in 11.2. Right, so that is it about 12c, enhancements in 12c, and now let's turn to my Explain-Ash tool, how you can use that together with the Diagnostic and Tuning Pack license. Yeah, the Explain-Ash output is then simply a script, so it clearly doesn't look as nice as the real-time SQL monitoring reports look like, but they offer a number of advantages. Of course, that's one of the reasons why I wrote the script. Otherwise, I could just have worked with the existing monitoring reports. The first thing I've already pointed out in terms of identifying skew. If we come back to our two questions, how can I identify skew? If I have a problem with skew, then the Explain-Ash output offers this activity timeline, which pretty much corresponds to what you see here. So this activity tab here, the representation is then what you get here, and here again you can clearly see that there is a sharp drop in activity. So it's the at sign here tells you about CPU activity, and the asterisk, the star sign, represents non-CPU activity, so which is a bit similar to what we see here, the CPU, and in this case then some other activity which is more obvious here from the graph, but you can see it here. It's the same way in the Explain-Ash output. You can also see here the details about the activity. But the most important point is this graph here, so that you see here clearly that there is a problem with parallel execution skew or not. And we can immediately come to this second point. How do I know whether I have a problem with skew or whether I have a problem with different degrees? You have here in Explain-Ash, in this activity timeline, you have this additional information which tells you which DFO tree was active. In this case, there was just a single DFO tree, and it has a degree of 16. So you can clearly see from this column here, so I will show you in a moment, whether there is some different degree issue involved, or this is just the same degree, and which degree you can also tell here from that information. So that is all available at a single point of information in the Explain-Ash output. The identifying then the skew on execution plan line level is then in Explain-Ash very straightforward, because Explain-Ash offers on execution plan line level this column here, which is simply called parallel execution skew, and in this case we have really a simple straightforward column, a simple straightforward indicator on execution plan line level that tells you which execution plan lines were involved or affected by the skew. And since this is the same example here, we can see here that the two execution plan lines that have the greatest indicator is again, of course, this line 12 and this line 5. So this corresponds, of course, what we have found out from the real-time SQL monitoring report. However, in addition to what this column here indicates, so that you at a very simple first glance can understand whether on execution plan line level where skew might be a problem, which operations are you have to look at in order to understand the skew. You have this parallel distribution information, which again is on execution plan line level available, and it tells you if the real-time SQL monitoring information is available and requested, then it tells you about the distribution of rows produced per operation. So we can clearly see here for this pair here that the producing DFO here has a pretty well distribution. So this line is not, this operation here, execution plan operation, is not affected by skew, although it is here shown as one of the main contributors to the skew. But obviously the line here above, this PX receive operation, is massively affected by skew, because we can see here that all the remaining parallel execution servers didn't receive a single row, but this P007 that we've already seen in the previous analysis based on the real-time SQL monitoring report, we can see that it receives all of these 2 million rows. Yeah, and the same we see confirmed here for the view operator and the hash join operation here. This is again something you can clearly tell from this row distribution here on parallel execution server level. So basically what you got from this part here, where we have filtered on the different, where we can filter on some of the parallel execution servers, this information I show right from the start in this column here, that we see how the rows were distributed among the parallel execution servers per execution plan line level, which gives you a very clear picture, although it looks a bit messy. If you look closely at the information, you can very clearly tell which operations are causing the problem, which operations are suffering from the problem, so that you can very easily understand what you might have to do in order to address the skew, which is why I ask these two questions in first place, understanding do we have a problem with this skew, and if yes, which operations are involved, affected, and causing the problem, so that countermeasures can be taken. So with this information provided by Xplan-Ash, it is very simple and straightforward on execution plan line level to answer this second question. What it else is, what's more with Xplan-Ash is that even if this real-time SQL monitoring information here is gone, it's no longer available, then these figures here that represent the number of rows produced per parallel execution server is no longer available, will simply be missing from this report here. However, since, as I pointed out, this information here is based on active session history, this indicator will still be there, which means that even if the real-time SQL monitoring report information is no longer available, you will get this indicator on execution plan line level, which typically is sufficient to tell where and why the skew on execution plan line level happens. So with Xplan-Ash, you can even when the report, the real-time SQL monitoring report is gone, you can get this, you will get this indicator here from active session history. And therefore, even without the real-time SQL monitoring report information, you typically can understand on execution plan line level what is happening in terms of skew. Furthermore, since it is based on active session history, this also means that you can get this information from the history of the active session history. So Explain-Ash can even generate this report from the DBA hist active session history information. So you can even generate such a report for executions that are only covered by your AWR history. So maybe for something that is that happened 30 days ago, depending on the configured retention. Furthermore, Explain-Ash supports custom repositories, so if you have some custom code that persists the more granular $$ active session history for a longer period than the standard AWR only every 10th sample persistence, then you can configure Explain-Ash to use your custom repository to access that information from your custom repository and draw such reports from your custom repository. And with the latest version of Explain-Ash, you can even persist the $$ SQL monitor and $$ SQL plan monitor information to a custom repository, and then you would be available to get these row distribution per parallel execution server, even for executions where the official real-time SQL monitoring report is no longer available, simply by pointing Explain-Ash to your custom monitoring repository. These customizations, how you can configure Explain-Ash to use such custom repositories, is something that I will demonstrate in a forthcoming tutorial. But at this point, I just wanted to point out that Explain-Ash has the flexibility to produce these reports without real-time SQL monitoring, from historic active session history, and even from custom repositories. So you can do a lot of things with Explain-Ash that are not possible with the built-in tools. Yeah, then what about the other limitation with multiple DFO trees in a single execution plan? How does Explain-Ash deal with those cases? We can have a look here at the corresponding Explain-Ash report for the execution that looks in real-time SQL monitoring like this. This was the one here that is a bit misleading because it tells you something about degree 15, but it wasn't degree 15, and it also is here, has this bug with this duplicated activity information. How does Explain-Ash deal with that? Well, Explain-Ash hopefully deals better with such cases. The first thing is that it already shows you here in the real-time SQL monitoring summary, which basically corresponds to this overview tab here. Basically what you get here is what Explain-Ash shows you here in this real-time SQL monitoring summary, if it's available. If the real-time SQL monitoring information is no longer available, then of course this section will be missing from the output. But it tells you here with this minimum degree and maximum degree, with this very the very obvious point, you can understand whether you have an execution with multiple degrees or with a single degree. So if we look at the output for the other execution that only had a single DFO tree, then you see here that the minimum and maximum DOP was the same here. So this is something, the first indicator, which is right on the top of the output, where you can understand whether you have to be a bit careful with the how you have to interpret the output, because you have because you deal with this multiple DFO tree thing. Then also some information that gives you a hint that something not that straightforward happened here with a degree of 15 it is pretty unlikely to end up with 64 servers, parallel execution servers requested. So again, that's something you can think about if you look at the information. Then you might understand, okay, how can I end up with 64 servers requested with a degree of 15, maximum degree of 15? I should have at most 30 servers requested and not 64. Another interesting information that the same information, is then basically repeated based on the active session history information. That is simply due to the fact that you might have the situation that the real-time SQL monitoring information is no longer available, and since 11.202 the degree used is also somewhere in the active session history information available. So again, if you can see here that you deal with different degrees. And just as a side note, here is one thing that is also quite interesting if you deal with parallel execution, that explain-ash tells you how much time or how many of the samples were related to redistribution of data. So you have with parallel execution, you have this overhead of redistributing the data, and you can actually spend a significant amount of time in this redistribution, because we are talking about redistributing giga or terabytes of data in memory. Although it happens in memory, or in terms of rack, it has to happen also across the interconnect. You can spend some significant amount of time in these redistributions, and you can see here that it tells us that from the overall time, or the overall number of samples that we have here for this execution, we have spent 30% of the samples in redistribution, which is not that obvious if you simply look here at the planned statistics, because this is all split across these different px send and px receive operations. So it's not that easy to sum the overall activity of all these different px send and receive things manually. That's something that real-time SQL monitoring doesn't provide, this summary, but explain-ash provides this summary. So you see, wow, I spent 30% of my time in redistribution, which gives you an idea of how much overhead the parallel execution causes. And then there is another summary available. It tells you how much of CPU time you have spent on the redistribution, because typically the majority of time you spend on CPU when doing the redistribution. So in this case we have a quite extreme case of 60% of CPU time spent on the redistribution. But this is due to my example that I made up here, but just to give you an idea, for complex execution plans it's not unlikely to spend up to 40% of your CPU time on the redistribution, which is for critical statements. This might mean that you should think about measures how you can minimize this redistribution. For example, if you implement full partition-wise operations like full partition-wise joins, you do not have to redistribute data, and therefore this overhead is not there with full partition-wise operations. Of course, the downside is you have to partition the data in a suitable way, and that's not always possible, and is something that you probably typically should design right from the start, and not something do afterwards as a performance improvement measure. But nevertheless, explain-ash tells you about this here, which can be quite revealing how much time you actually spend on redistributing the data. Then you get here this average active sessions information, which is basically corresponding to the graph here again. So you see here this graph, and of course you have to be very careful with averages, because averages can be quite misleading. Nevertheless, for simple executions like the one here, where we have only a single degree and only a single DFO tree, this average active session information can be quite helpful, because at a first glance you get an idea. We had a degree of 16, but we had an average active sessions of 12 and a middle value, a median active sessions only of 3. So that is a clear indicator that even this average and this median value already tells you there was a problem with skew, because I only had this simple degree of 16, so there's no issue with multiple DFO trees in this case here, and I have an average and a median that is far below this 16, then you can already tell from this value here, from this average and this median, you can already tell you have a problem with skew without looking at any further information. If you wonder about these two average active session values that you see here, one this average active sessions total and the other one average active sessions active, the difference between the two is that this one here is really from the first to the last sample that is found in the active session history, whereas the second one here, this average active sessions active, is only for those samples, the average where at least one active sample was found. So if you have an execution with a significant amount of samples where no activity is sampled at all in active session history, then these two will be different. And for those cases where you have an activity in any way for every sample, then there won't be a difference. But for those cases where there is a difference and you have a significant amount of no activity at all, then this average active session value here will be a bit greater than this one, depending on the number of samples without any activity at all. Of course, sometimes this can be helpful, but in general you can use this value here as the more important average value, because it is for the overall time of the samples that are found in active session history from the from first sample to last sample. Right, then back to the multiple DFO tree plan. Another part of the Xplan-Ash output is here then the details of the DFO trees. And that is also something that you do not have in that way in the real-time SQL monitoring report. Several very important information that is made available here is again the degree per DFO tree. So you now see here very clearly that the first DFO tree had a degree of 2, whereas the other two DFO trees, these 3 here that are shown in total, these two had a degree of 15. So, and we can also see that we get here the average and median active sessions per DFO tree. So in this case it becomes obvious that we do not really have a problem with skew, because the averages are pretty close to the actual degree. So on average, and the middle value also seems to support this, we do not seem to have a problem with the work distribution within each DFO tree. And then another point, another graph that is quite helpful in understanding the pattern of activity. We can clearly see here with this time active graph that each of the DFO trees was active one after the other. If you had a look at this time active graph for the examples that I showed in the previous parts of the tutorial, where the multiple DFO trees were active at the same time, this would clearly be shown here in the time active graph, that you would see here that the different DFO trees were active concurrently at the same time, and then these DFO trees here clearly were active one after the other, which is quite helpful in understanding how these different DFO trees interact with each other. And you get this also at a high level overview information. Then this section here I think I haven't mentioned yet, and it probably makes sense to show this section for the other execution. This section here, the parallel worker activity overview, more or less corresponds to this parallel tab here. So again, it shows the amount of information the different kinds of information broken down on parallel execution server level. And here again, the information is separated per DFO tree and per set, so that corresponds to this group information, which basically corresponds to different DFO trees, and then the different sets. So that is the same kind of information broken down here. Of course, I should use this here as the counterpart report, real-time signal monitoring report. So you can see here these null sets that show up here in the xplan-ash output are simply meaning that this activity here in terms of execution plan line, so the samples in the active session history were related to execution plan lines that cannot be related to one or the other set. So in this case it was the execution plan line 2, and if we look in the execution plan, the plan line 2 is here this PX coordinator, and this PX coordinator is clearly an activity in the execution plan line that doesn't have to do anything with either of these DFOs, with either of these sets of parallel execution servers. So in principle, only the query coordinator activity should show up for that plan line, but as you can see, this is not that strict. Here we have, as it looks like, we have here for whatever reason 2 samples of parallel execution servers that are related to this PX coordinator plan line, whereas this SQL plus here, this query coordinator process activity is expected, and therefore this null set ID shows up here, because it can be related to the DFO tree number 1, but it cannot be related to any set. But the remaining activity is then either relating to set number 1 or set number 2, which again corresponds to what you see here in the real-time signal monitoring report. And again, this activity graph then I think a bit more obvious than this graph here shows us that this P007 in this case has a quite different, significantly different activity pattern than the other servers within the same set. And xplan-ash then offers more information, like the top active plan lines, the maximum PGA per process, the top activities, and so on. These are all information, and even if we had some I/O figures, you would even get the I/O figures from 11.2 on. These are all things that you do not get from real-time signal monitoring, and but xplan-ash shows them. But the most important parts are here on the left-hand side of the output, this activity graph, and the aggregation of the information per DFO tree and set. Yeah. Then on execution. On the activity timeline, as I've already mentioned in the other report, this is actually the report. Let's switch back to the other one here. This is the one with the multiple DFO trees. So we do not see much difference in activity per set here. We see here a null part here, DFO tree null and set ID null. This means that we have here activity that cannot be contributed to any of the DFO trees or any of the sets, which probably means that we have either the execution plan line 0 or null. In this case, we have samples where we do not have an execution plan line at all in the active session history, which sometimes happens if we have some parsing activity, as you can see here with this cursor pin as wait on X. This is what I mentioned with when each time a DFO tree starts, activity like this can happen. So within during the execution of a parallel executions, you might see weights like this because the query coordinator initializes the different parallel execution servers, and these might have to parse then the existing cursor in order to join the execution. So the activity timeline that I wanted to show is here. Now we see here a clear indication that we have this lower activity period at the beginning, which corresponds to this graph. Which corresponds to this graph here. So we see here this lower period of activity, which we see confirmed here in the explain-ash output. But now you see immediately that we have here a different degree of parallelism. In this DFO tree number 1, we only have a degree of 2, and again we see very clearly that this doesn't look like really like a skew problem, but simply a problem of different degrees. And we see here with this higher level of activity, the second DFO and the third DFO tree are then started, and you can also see that explain-ash doesn't fall into the trap of this data duplication. So rather than showing here some activity of 60 servers and more, like the official report does here, we see here a more reasonable degree, a maximum of 30, and then something around 15, which looks much more reasonable for a degree of 15 rather than 60 or even more, higher than 60. So explain-ash can cope with this multiple DFO tree thing much better than the official report does. On execution plan line level, again, I've already mentioned these different kinds of information here. We can also see confirmed that there wasn't really too much about skew. There was a bit of skew here recognized by explain-ash, so we had some periods of activity here which we can see here confirmed, where we didn't really reach the 15, and we also didn't reach the 2 here, and therefore explain-ash will mark those execution plan lines that there was some skew, but it's not really that significant, because the indicator would then have to be somewhere here that you would see that it's really something that you have to care about. So you can see here with this parallel execution skew indicator that this is not really, this problem here is not about skew, but it's about the degree. Yeah, so and regarding the availability of the report, I've already pointed out that explain-ash can work with SASH, at least to address the first question, not the second question. Then explain-ash works without the real-time SQL monitoring information, so it can, as the name suggests, it can simply use the active session history information to produce such reports. You will then miss, of course, the monitoring related information, but you will always get this skew indicator information based on ash. You will get that even from the historic ash information, and as I pointed out, you can even get it from the custom repositories of active session history information. You cannot get that information from SASH, although, because SASH, without the diagnostic pack license, you do not get the relation to the execution plan line in active session history. That's only made available via the diagnostic pack information that the official active session history then includes. So well, I think that's it. So I hope you got an idea that for answering these two questions, the official real-time SQL monitoring report has some shortcomings. In particular, this identifying the skew and execution plan line level is up to version and including version 11.2. is a problem because there is simply this information is not made available. You can see that by looking at the raw report or by looking at custom query outputs based on the $SQL monitor, $SQL plan monitor information in 11.2 and also in 11.1, but it's not made available via the official reports. This changes a bit in 12c, where you have these different options that you can choose and then get an idea about the execution plan line level activity. Then we have the problems with these multiple DFO trees and these various inconsistencies, misleading information about the degree, no information about different degrees, and also this bug with this duplication of activity and the availability. And all of these things should be addressed with my explain ash tool. And one final word is that most of this information is also available if you use explain ash with version 11.1. So for those that are still on 11.1, probably not many anymore. But if you still run on 11.1 and use parallel execution, all of this nice information here on execution plan line level, this skew indicator, and also this distribution on parallel execution server on execution plan line level, and also this activity graph, which is also something that the official real-time SQL monitoring report in 11.1 doesn't provide. All this information is also available in 11.1 for those that are still working with 11.1. All right, so I think that's it